The epigenetic regulation mechanisms of peptides in skincare. Epigenetic regulation refers to influencing gene expression without altering the DNA sequence. Peptides in skincare products influence skin aging, repair, and regeneration through histone modification, DNA methylation, and non-coding RNA regulation. Histone modification, acetylation, and methylation involves histones that help package DNA into chromatin, and their modification affects the on-off switch of genes. Histone acetylation, promoted by HATs, relaxes chromatin structure, making genes related to collagen production and cell renewal easier to express. Histone deacetylation, promoted by HGs, tightens chromatin, suppressing gene expression, which may accelerate skin aging. Histone methylation, promoted by HMTs, may promote or inhibit gene expression, depending on the location of methylation. Relevant peptides: palmitoyl tripeptide 1, palmitoyl tetrapeptide 7, matrixyl 3000, promote histone acetylation, enhancing collagen and hyaluronic acid production. Acetyl hexapeptide 8, arginine, may regulate histone modification, reducing the expression of genes associated with muscle contraction and wrinkle formation. 2. DNA methylation, gene silencing or activation. DNA methyltransferases, DNMTs, add methyl groups to CpG islands in gene promoter regions, which typically suppress gene expression. Peptides can influence DNMT activity, preventing excessive DNA methylation that leads to skin aging. Relevant peptides: copper peptide, GHK-HU, promotes histone demethylation, restoring the activity of genes related to tissue regeneration, accelerating wound healing and skin repair. Regulation of non-coding RNA, microRNA, and long non-coding RNA. MicroRNAs, miRNAs, are a class of RNA molecules that regulate gene expression, primarily affecting post-transcriptional regulation. Certain peptides can alter the expression of miRNAs, affecting genes related to inflammation and extracellular matrix remodeling. Hexapeptides can regulate miRNAs, reducing pro-inflammatory responses and keeping the skin youthful. In summary, skincare peptides regulate gene expression by influencing histone modification, DNA methylation, and non-coding RNA regulation, thereby enhancing collagen synthesis, reducing inflammation, and promoting skin repair, making them powerful ingredients for anti-aging and regenerative skincare. Are you interested in specific peptides or their mechanisms of action? The pathways for transdermal absorption of various peptide ingredients and how they are absorbed by the skin. The transdermal absorption pathways and mechanisms of peptides. Peptides are bioactive molecules composed of amino acids widely used in skincare products for anti-aging, repair, and whitening. However, due to their typically larger molecular weight and high water solubility, their transdermal absorption is somewhat limited. Here are the main pathways through which peptides penetrate the skin. 1. The skin barrier and challenges of peptide absorption. The skin consists of 3 layers: stratum corneum, SC, the outermost layer composed of keratinocytes and lipids, preventing large molecules from penetrating. Epidermis, avascular, peptides must enter through intercellular spaces or special mechanisms. Dermis contains blood vessels and cells, further transporting peptides into systemic circulation. The transdermal absorption pathways of peptides can be divided into 3 main mechanisms. 1. Transcellular route. Peptides directly penetrate cell membranes into cells, passing through the epidermis to reach the dermis. 2. Intercellular route. Peptides traverse the lipid layer between keratinocytes, gradually permeating into the dermis. 3. Appendageal route. Peptides enter the dermis directly through microchannels such as hair follicles, sebaceous glands, and sweat glands. 2. Absorption methods of various peptides. Small peptides, less than 500 Da, absorbed through transcellular absorption. These peptides comply with the 500 Dalton rule and can penetrate the skin more easily, for example, palmitoyl tripeptide 1, palmitoyl tetrapeptide 7, acetyl hexapeptide 8, arginine. Absorption pathways. These peptides typically undergo lipophilic modifications, such as palmitoyl modification, to enhance lipophilicity, making it easier for them to penetrate cell membranes through transcellular pathways and enter the epidermis and dermis layers. Once inside the cells, these peptides affect cell signaling, such as stimulating collagen synthesis or relaxing expression muscles. Large peptides over 500 Da are primarily absorbed through intercellular pathways and appendages. Due to their larger molecular weight, these peptides find it difficult to penetrate the stratum corneum and typically rely on intercellular pathways or absorption through follicles and sweat glands, appendage pathways. For example, copper peptide, GHKCU, signal peptides, such as EGF growth factor, absorption pathway, penetration through the intercellular lipid layer, slower speed, absorbed through hair follicles, entering the dermis and binding with cell receptors. Enhanced absorption through nanocarrier technology, liposomes, nanocarriers, such as liposomal encapsulation to improve permeability, special peptides, penetration enhancers, and nanotechnology assistance. Due to the larger size of peptide molecules, skincare products often use penetration enhancement techniques, such as liposomes, encapsulating peptides to enhance permeability. Nanoemulsion, increasing the lipophilicity of water-soluble peptides to improve skin absorption. Microneedling, creating microchannels for peptides to enter the dermis directly. Representative peptides, EGF, epidermal growth factor, requires nanotechnology or microneedling for absorption. Peptide complexes, such as peptide chain combinations, usually paired with penetration enhancement techniques like carrier systems. How to enhance the transdermal absorption of peptides? Due to the absorption of peptides being limited by the stratum corneum, the following techniques can enhance their permeability. 1. Lipophilic modification, such as palmitoyl modification, increases lipophilicity and enhances transcellular absorption. 2. Carrier technologies, such as liposomes and nanocarriers, help large peptides penetrate the stratum corneum. 3. Follicular absorption. Larger peptides, such as GHKCU, are absorbed through hair follicle channels. 4. Penetration enhancers, such as ethanol and silanization techniques, increase peptide absorption rates. 5. Physical techniques. Microneedles or radiofrequency techniques temporarily open the skin barrier, enhancing peptide penetration rates. Summary. Small peptides, 500 Da, absorbed through transcellular absorption, such as matrixyl, palmitoyl tripeptide 1. Large peptides, 500 Da, absorbed through intercellular absorption and follicular absorption, such as GHKQ. Special peptides, such as EGF, require nanotechnology or microneedles to assist absorption.